So this is Mrs. Ward, and this is the second half of 7.4, partial fractions. So we're going to still continue partial fractions and the decomposition of those fractions. So I just want to review what we've already learned. So if I had something that was like x plus 3 over, let's say, x to the third plus x plus 2, let's make that x squared plus 2 raised to the second power. If I had that, when I go to factor it, this can actually be written as x times x times x, and then this would be x squared plus 2 times x squared plus 2. And the reason why I'm writing that is because I want you to see that you have this x cubed. It looks like it's cubic raised to the third power, and it is, but the factor is actually x times x times x, which makes the factor what's called a linear, and it's a repeat linear, and it's repeating 3 times. So the way we handle that is we do the a over x plus b over x squared plus c over x to the third. And remember, we want to do that so that we have, when we find our least common multiple, like if I gave the partial fraction to somebody and they want to come find the least common multiple, they know that that x is raised to the third power. Somewhere in the denominator, you have to have that x raised to the third power. Now, to do the quadratic, we talked about a quadratic. You're going to do the, oh, it's not going to be b anymore, sorry. It's going to be dx plus e, and then I'm going to put that over x squared plus 2, and the reason why I have the linear is because this is raised to the second power, and then the repeat, because I do have this twice, follows that same pattern. So I'm going to do fx plus g, and then this will be over x squared plus 2 squared. I would never ask you to solve something like that, but you do have to know how to set up the pattern. So when I go to do a repeat quadratic, this one we're just going to write the form. We're not going to solve. So when I do this, I'm going to do ax plus b over x squared plus 4. Maybe we should do this one. And then cx plus d over x squared plus 4 squared. Now when I go to solve this, remember my least common multiple is this, x squared plus 4. So in order to get that, I would multiply this one by x squared plus 4. But this one already has that x squared plus 4. So this one I'm just multiplying by 1. So I'm not really multiplying by anything. I'm going to write the x to the third plus 3x squared minus 2x plus 7. I'm going to FOIL this. And I'm going to try and do it right. Ax to the third plus bx squared plus 4ax plus 4b. And then this cx plus d is not changing because I'm multiplying it by 1. So then what? Hold on. So now I'm going to get out my highlighter, and x to the third, no other x to the thirds, x squared, no other x squareds, linear, 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 and then finally my constant, constant, and constant. That's a d. So when I write my equations, I'm going to have 1 is equal to A. I'm going to have 3 is equal to B. I'm going to have negative 2 is equal to 4A plus C. And I'm going to have 7 is equal to 4B plus D. So now I'm going to put, since A is equal to 1, I'm going to put that in here. So I'm going to have negative 2 is equal to 4 times 1 plus C. So negative 2 is equal to 4 plus C. C is equal to negative 6. And then to find B or D, I'm going to say 7 is equal to 4B, which is 3 plus D. So 7 is equal to 12 plus D. D is equal to negative 5. And then substituting back in, I'm going to have ax, so ax plus b, and that's over x squared plus 4 plus c x plus d over x squared plus 4 squared. You can see the answer that way, or you may see it if I change this to a minus and distribute the negative sign. This would be 6x plus 5. Either answer is fine. You don't have to change it if you don't want to, but that's just the other format that you're going to see. Okay, grabbing the next one. This one has a repeat linear, so go ahead and try, like pause the video and try the repeat linear. Okay, what you should factor is x squared as x minus 7. So this will be a over x plus b over x squared plus c over x minus 7. Now when I go to multiply, I'm going to multiply this by x times x minus 7, this by x minus 7, and this by x squared. So I don't have anything with that's squared or linear, so I'm going to think of it as 0x squared plus 0x plus 9 is equal to ax squared minus 7ax plus bx minus 7 plus cx squared. My coefficients for x squared, so I'm going to have 0 is equal to a plus c. Then for x, I'm going to have so I'm going to have 0 is equal to negative 7a plus b. And then finally, my 9 is going to equal, that's a b. My 9 is going to equal negative 7b. So that means that b will equal negative 9/7. Putting that in here, I'm going to have 0 is equal to negative 7a plus negative 9/7. So 9/7 is equal to negative 7a. A is equal to negative 9 over 49. And then lastly, I'm going to put that into this equation and have 0 is equal to negative 9 over 49 plus c, and c will equal 9/49. Okay, when I go to write them, I am going to do, oh wait, I'm going too far up. Here I am. So x is equal to negative 9 over 49, and that's over x, plus b, which is negative 9 over 7 over x squared, plus c, which is negative 9 over 49. One of these is positive. Oh, c is positive. Over x minus 7. You have to get rid of the fraction within the fraction of the complex fraction. So what I decide to do is I'm multiplying both the numerator and the denominator by 49. When I do that, when I take this times this, I'm going to get negative 9. This times this, the 7s will simplify, and I'll be left with 7 times 9, which will be negative 63. And then this times this will be positive 9. My denominator, I'm going to leave that 1 over 49 outside, and then I'm going to have x, x squared, and x minus 7. And that's my final answer. Okay, we did not do this one. This one we talked about in class, so you're still going to do it the same way. You're going to have a over sine of x plus b over sine of x minus 1 because they're both linear. So I'm going to have cosine x is equal to a times sine of x minus 1 plus b times sine of x. So then I distribute my a, and I'm going to have a times sine of x minus a plus b times sine of x is equal to cosine of x. So these have they're coefficients of sine of x. So I have a plus b, but there's no sine of x over here, so I'm going to set that equal to 0. And then that negative a, I'm going to set it equal to the only thing that's left, which is cosine of x, which means that negative cosine of x is equal to a. And since a plus b is equal to 0, that means b is equal to positive cosine of x. So my final answer is going to be negative cosine x over sine x plus cosine x over cosine, oh, sine x minus 1. This can be simplified to negative cotangent. You cannot simplify the other one, and that is my final answer. Okay, we did one like that. Okay, this one, okay, and this last one I'm going to do, when I look at it, remember you have to check and make sure that it is a proper fraction. And proper fraction for rational polynomials means that the degree of the numerator is less than the degree of the denominator. So in this case, the degree of the numerator is 3, the degree of the denominator is 2, so that means it is not a proper fraction, so I have to first divide it, and I'm going to practice long division. So when I do this, the x to the third goes in the box. So I'm going to have x to the third. I'm going to put in a 0 x squared to hold my place, minus x plus 3. And then outside, my divisor is going to be x squared plus x minus 2. Then I am going to ask myself, what do I have to multiply x by to get x to the third? And you say x, so I'm going to put an x up there. Then I take that x and I multiply it by all three terms. So I'm going to have x to the third plus x squared minus 2x. Then remember you subtract. So here I'm going to subtract, which means all my signs are going to change. So this is negative, this is negative, this will become a positive. And so the x to the thirds will equal 0, and I'm going to have negative x squared plus x plus 3. Then I ask myself, what do I have to multiply x squared by to get negative x? And you should say negative 1. So now I'm going to multiply everything by a negative 1. So all these signs will change. So there'll be negative x squared minus x plus 2. And then I'm going to go ahead and subtract that. And when I subtract that, that means all my signs will change. So I'm going to have 0x squared. And then this will be 2x minus 1, or plus 1, sorry, 2x plus 1. So what I have for my answer, and this is what you did with Mrs. Pesic, is you have x minus 1 plus your remainder written over your divisor. Now what we're going to do for the partial fraction decomposition is we're going to leave this alone, and we're going to split this up into the two parts that it can be. So the denominator factors is x plus 2, x minus 1. So I'm going to think of that as a over x plus 2 plus b over x minus 1. So when I solve this, I'm going to have 2x plus 1 is equal to, and then a times x minus 1 plus b times x plus 2. And you're either substituting in the 1 or negative 2, or you're distributing. I'm going to distribute ax minus a plus bx plus 2b. So my a plus b is equal to my coefficient of x, which is 2. And I can highlight that if you like. And then my constants are 1, negative, and that. So when I do that, I'm going to have 1 is equal to negative a plus 2b. Now this will be a simple elimination problem. I'm going to have 3 is equal to 3b, which means b is equal to 1. Then I'm going to solve for a, so I'm going to say 2 is equal to a plus b, which I just said was 1, so a is also equal to 1. So my final answer, when I go to find my answer, I'm going to put 1s in here, but I'm also going to have to remember this x minus 1. So I'm going to say x minus 1 plus 1 over, I can't remember which one I wrote first, x plus 2 plus 1 over x minus 1. And this is my final answer. So if you have a fraction, a polynomial that is not a proper fraction, you're going to have to do the long division first. And I believe that's it. This is not the homework. You're doing the one online that says homework day 2. All right, I hope this helps, and I'll see you next time.